Influenza is a serious disease that affects millions of people every year. Between the two flu seasons, there are over 3 million cases of severe illness and nearly 500,000 deaths worldwide. Of those, 36,000 deaths occur in the US alone. However, over the past decade, we've made major strides in information technology, hardware, and software. These advances have helped to significantly improve the efficiency of medicine. E-prescriptions, for example, allow patients to obtain quicker access to medicines and pharmaceuticals. And telemedicine helps to optimize medical appointments by reducing the number of face-to-face sessions needed. However, there's still so much more that technology can do for public health. That's why the Outfluenza team is proud to present Outfluenza, a powerful analytical engine that can analyze data from e-prescriptions, quickly identify prescriptions treating influenza, and render those findings visually for the ease of a user.
Outfluenza is an engine that is easily accessible by anyone who has access to the internet. Its main purpose is to provide doctors and analysts with the data necessary to track, predict, and examine the spread of the disease. It represents the data graphically as well as demographically. This brings us to our intuitively designed and engineered homepage. For new users, we have created an additional page where they can go to understand the different features that Outfluenza has to offer. These features being search, visualize, and predict. Outfluenza first gathers unstructured e-prescription data from the SureScripts network and organizes it for you so you can easily search for detailed statistics and trends. Outfluenza then provides beautiful visualizations to show you how the influenza is spreading, as well as instant statistics on the demographic breakdown and rate of spread of the disease. Finally, Influenza applies machine learning algorithms to predict how influenza will spread in the future and alerts doctors to outbreaks before they happen. Moving back to the home page, users see the map of the United States on the left-hand side, with each state colored a different color based on the severity of influenza in those states. For example, if we hover over a given state like California, we notice that about 13% of all reported cases in the United States so far have been from that state. Also, it tells you how fast influenza has been spreading in that state. If we click on that state, we get a closer look of the map and a further breakdown of the state itself. For example, if we look at Los Angeles, we notice that 18% of all the cases in California itself come from that county, whereas other counties over here have almost no cases of influenza being reported. By clicking on any of those places again, we can zoom out. On the right-hand side of the map, you can see national trends across the United States. For example, we have a list of the top 3 states with the most number of patients. We also provide for you the top most infected zip codes and the states in which they reside in. Finally, we also have a list of the top most prescribed drugs across the United States. Instead of clicking on the map, users can also click on the search bar and type in the name of the state that they're interested in. For example, if we type in Virginia, we automatically zoom into the state of Virginia and get more detailed information on the map as well as the right-hand side of the page. For example, here we can see that there have been no new cases of influenza reported in the state of Virginia over the past month. And we can also see that the zip code 23322 has had the most number of cases in the past year. If we click on the age distribution, we can see that people between the ages of 10 and 19 have had the most number of reported cases, whereas people between the ages of 50 and 59 have had the least. If we look at the gender breakdown, we can see that more females have reported being infected by influenza than males in the state of Virginia. Additionally, we can also view the number of cases of influenza over a time period. For example, over the past week, there have been an equal number of cases reported in Virginia. However, over the past few months, the number of cases has reduced. Finally, We can see that over the past few years, on the other hand, the number of cases has actually spiked at 2013. Users can also download the data presented on the right-hand side by clicking the Download CSV file button. By doing so, users can collect raw data from our website and make sure that they do their own analysis in the future. Outfluenza believes that it's also important for users to track influenza even when they're not on the platform. Therefore, we provide a sign up and login button so that users can be notified whenever there is an outbreak or an increased number of cases of influenza reported for a specific zip code or state that they might be interested in. Finally, using our machine learning algorithm, we can use the slider at the bottom left corner to see the change in the severity of cases across the United States. Outfluenza is not only beautiful and functional, but it also has a powerful backend. The engine constantly collects e-prescription data and quickly parses and integrates the new data into the existing model. It extracts all useful information concerning the patient's age, gender, prescription, and location. Security, of course, is very important to us. We do not provide or store any personal information such as names or addresses of the pharmacist, prescriber, or patient. We utilize support vector machines to train our prediction model. Using supervised learning, we're able to predict the number of outbreaks in a given zip code on a given day. These predictions can aid health organizations prepare for outbreaks in their area. We have a long way to go in terms of reducing the fatalities related to influenza, but this is just the beginning.